Okay, hi guys. This portion I'm going to be walking through the homework solutions to worksheet 1, day 1 homework. For some reason I can't upload worksheet 1A, but thankfully those were the easier questions, so if you have any questions, feel free to ask them tomorrow or on Friday. As always, feel free to pause or fast forward if you don't need certain parts. From a set of 5 discs numbered 1, 2, 3, 4, and 5 respectively, one disc is selected at random and the number on its face recorded. The disc is returned and another selection is made. That's key. The fact that I am putting that back changes things up. The second number is recorded. A 2-digit number is formed, the first disc being the tens digit and the second disc being the ones digit. What is the probability that the number equals? Okay, equals 41. But before I do that, I'm going to figure out all the different denominators. The fact that I'm able to return that disk means that repetition is allowed. So I'm just going to put off to the side here. My denominator will be 5 options for my tens digit and 5 options for my ones digit. So I have 25 possible outcomes for the denominator. Well, 41, how many ways are you going to get 41? Just one. 1 over 25. Or you can think about it as 1/5 times 1/5. Now we've got is even. Well, I'm going to think about, I know the denominator is 25, so the numerator will be, doesn't matter for the first one, be 5. But then to truly be even, I need to have 2. Which will result in 10 numbers out of my possible 25, and we are left with a 2/5 chance of selecting or recording an even number. Now being less than 30, well, that means I must start with either a 1 or a 2, so I have 2 options, and then I've got 5 options. So I've got, once again, 10 out of my 25, or I've got a 2/5 chance. And finally, divisible by 5. To be divisible by 5, I must end in a 5. So I've got 5 there, and then I have, excuse me. I said 5, meant to write 1. So I have 1 option, and I have 5 options for my tens digit, which gives me 5 out of 25, or I have a 1/5 probability of getting a number divisible by 5. Okay, the next one, rolling 2 standard dice from find the probability of. Well, you can either use your dice chart that we did last chapter. That's, you show all the details, or you can just go ahead and create the quick one that shows your sum and the number of ways. Let me zoom in a little bit. So I know my smallest sum will be 2. I'm going to work my way up to 12. Okay, so that's old news. And now we're just going to go ahead and find the probability of rolling a sum of 7. Well, sum of 7. We have a sum of 7 6 times out of our 36, or 1/6. A sum of 8 or 10. Well, those are mutually exclusive. Either I have a sum of 8 or a sum of 10. So let's see, sum of 8 would be 5 out of 36. Plus sum of 10 would be 3 out of 36, resulting in 8 out of 36, or 2/9. An even sum, well, either you're even or you're odd. It is equally likely. Therefore, we get 18 out of 32 or 36, or just 1/2. Or you could add up all of your evens. You could say 1 plus 3 plus 5 plus 5 plus 3 plus 1. And finally, the sum is greater than 8. Well, that would be a sum of 9, 10, 11, or 12, which adds up to be 10 of our 36, or 5 out of 18. Okay, number 3. Oops, excuse me with that. I always draw all over. Okay. Number 3, 50 identical tacks are tossed and allowed to land freely. 33 land with their point up and 17 land with their point down. If this is assumed to be the probability model for the tacks landing point up and down, then what is the probability that if 3 tacks are tossed, they will all land point down to the nearest 4 decimal places? Well, that's saying I want it to land down and land down and land down. Well, the probability of landing down is 17 out of, well, we had 33 and 17, so 17 out of 50. And 17 out of 50 times 17 out of 50, because we want them to all land down. And multiplying that out to 4 decimal places, we get 0.0393. Okay, moving along to 11. Okay, number 11. A bowl contains 10 red, 20 blue, and 10 white. If 2 chips are selected at random without replacement, find the probability that they are the same color. Okay, so we need to set up our cases here. We can either have, since we're selecting 2, we can either have 2 red or 2 blue or 2 white, since we are interested in only having the same color. Well, this is pretty basic now. That means I have 10 reds and I want to choose 2. You might not do this, but I like to always finish it off. I have 20 blue and I'm choosing 0. I have 10 white and I'm choosing 0. Or I'm comfortable with 2 blue. So I have 10 red, I want none. And I have 20 blue and I want 2. And I have 10 white and I want 0. Or finally, I have 10 red, I want 0. And I have 20 blue, I want 0. And I have 10 white and I want 2. But remember, the difference from this chapter to last is that now we're doing probability. So now we've got to account for all the possible ways of selecting 2. It could be 2 red, 2 blue, 2 white, a red and a blue, a red and a white, a blue and a white. So that'll just be 40 since we have the 10 red, 20 blue, 10 white. So 40 total, and we're selecting 2. And then you'll end up with 45 plus 190 plus 45 over 780, which does simplify to 14 over 39. But I know you guys are comfortable with that. Okay, moving to 14. The 20 faces of an icosahedral, die are numbered 1 through 20. All outcomes are equally likely. If each of the 6 players roll this die once, what is the probability that at least 2 of them will roll the same number? Okay, at least tells me right away I'm going to probably do a complement. Round to the nearest thousandth. So probability of at least 2 with same number tells me I will equal that to 1 minus the probability of all different. And I know that I have 6 players and I have 20 sides. So just like the birthday problem, my first roll, I have 20 out of 20 options. Then, because I want all different, I've got 19 out of 20. I'm going to work my way down. 17 out of 20, 16 out of 20, and finally 15 out of 20. Calculating that out in your calculator, you get approximately 0.564. And finally 18. Okay, Jill is randomly dealt 13 of the 52 cards from a standard deck. Rounded to the nearest thousandth, what is the probability that she gets at least one of the 4 aces? Okay, so probability of at least one ace will be equal to 1 minus the probability of no aces. Well, that's not bad. 1 minus, well, let's figure out no aces means I cannot have a single ace in my hand. That means I have 48 options to choose from. Take my 52 and erase my aces from there. And it says I'm dealt 13, so 48 C13. But remember, it's probability, so we have to now put it over our total number of options, which is my 52 cards, selecting 13. And this comes out to be approximately 0.696. Okay, so once again, I apologize for not putting up worksheet 1A. I'm not sure why it's not loading for me, but we'll have plenty of time in the next few days to answer any questions. Feel free to email me. I hope you guys have a great day, and I'll see you tomorrow.